Hey guys, today I'm going to be talking about a very interesting series of numbers known as the Fibonacci sequence, which is named after Leonardo of Pisa, an Italian mathematician from the Middle Ages. Now, what makes this particular collection of numbers so interesting is that its patterns are found in various aspects of life, such as art, nature, and the human body. Let's start by exploring an investigation Fibonacci conducted to see how fast rabbits could breed. His investigation was based upon the following assumptions. The process starts off with a baby rabbit pair, which means we have a baby female rabbit and a baby male rabbit. The rabbits can only reproduce once per month. They can start reproducing when they are 1 month old. They always produce a baby rabbit pair, which consists of one female and one male rabbit. And rabbits never die, which means the process keeps on going on forever. Let's name the rabbit pair that we started off with A. So A is a baby rabbit pair, which means they are not old enough right now to reproduce. But after 1 month passes, they become an adult rabbit pair. So pair A produces pair B, and B grows up. Meanwhile, A reproduces C. Here, C grows up. A reproduces, and now there's D, and then B produces E. So let's count up the number of rabbit pairs. Here we have 1, 2, 3, and 5. Now all of these numbers, 1, 2, 3, and 5, they're all part of the Fibonacci sequence. The sequence is 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and so on. One, 2, 3, and 5 are in the sequence. And if you continue this process, you notice that if you keep counting the number of rabbit pairs, all of those numbers fall in the sequence. And you may have already figured out the pattern in the sequence. The pattern is that each number in the sequence is found by adding the two numbers that come before it. So, for example, this 2 is found by adding the 1 and the 1, since the 1's come right before it. And this works with any number in the sequence. So with that being said, we can write a rule for the sequence. The rule is xn is equal to xn minus 1 plus xn minus 2. So let's just say n is equal to 9. That would mean x9 is equal to x8 plus x7. And this just means that the 9th term is equal to the 8th term plus the 7th term. So let's go through and see what the 9th term is. The 9th term is 21. So 21 is equal to the 8th term, which is 13, plus the 7th term, which is 8. So that's just how the rule works. Now, if you divide any two successive Fibonacci numbers, you will see that they get a number which is very close to 1.618. 1.618 is just a golden ratio. Now it's not exactly 1.618, but it's approximately that. So the golden ratio is approximately 1.618. And if you divide any two numbers that are right next to each other, you see that they get you a number that's very close to that. Now note that the bigger numbers get you much closer to the golden ratio than the smaller numbers. So like, obviously 2 divided by 1 is 2, and that's not very close to 1.618. But as you get into the bigger numbers, such as 34 divided by 21, so I'm going to go ahead and put that in my calculator. 34 divided by 21, that's equal to 1.61904, and that is super close to 1.618. And this works for all the numbers, so that's just something that's very interesting about this sequence. If you draw squares with the lengths of those Fibonacci numbers, you would see that they fit together perfectly, because 1 plus 1 gives us the side length of 2, and 2 plus 1 gives us a side length of 3. And with that pattern just continues. And you can see that a spiral is created. The red line is the spiral. This spiral can be seen in so many places in nature. These are just a few examples. There's so many examples out there. If you look closely, if you look at nature, you can find so many examples of spirals. So like the seeds in a sunflower, those make a spiral, and galaxies, the shells. There's so many different examples of spirals in nature. If you count the numbers of the number of petals on flowers, you see that those numbers are all Fibonacci numbers. 1, 2, 3, 5, 8, 13, 21, 34, those are all Fibonacci numbers. Now that's super cool. It's like it's nature's code. Like we said, 1.618 is approximately the golden ratio. So this part, this hand is 1, and this is 1.618. And that's kind of like saying this 34 over here is 1.618, and this 21 right here is a 1, because 34 divided by 21 gives you a number that's super close to 1.618. So that's just another cool thing. It shows that different body parts, they have this ratio when it comes to how their sizes compare. If you look at the human body, the ear, you can see that the spiral gives you the shape of the ear. Or this face, you can draw a spiral in it. Shells, we already saw an example below, but you can see the spiral here. This can also be used in nature. The famous painting, the Mona Lisa, it's super famous, and it uses the golden ratio for proportions. As you can see, this image can also be divided into equal parts, this proportion, the spiral that it's created. Each part is approximately 1.618 times bigger. So those are just some cool examples of how this concept can be applied to nature, to art, to the human body. And those three are not the only areas in which this concept applies. There's so many different areas, like even music, coding. There's countless number of aspects of life in which the Fibonacci numbers, the golden ratios, kick in. But that's it for this video. I hope you enjoyed.